All right, so in our last lesson we went through our three trig functions and we found side lengths and angle measures. And you see that in this lesson, so we're in Unit 8, Lesson 5 on page 103, we just labeled this more trig because what we're going to do is just really repeat what we just did in the last lesson just to give you some additional practice. So I'm just going to run through a handful of examples once again just so you can kind of see how we set up those trig functions, all right, see how we solve for sides and angles. And just let you see all that work. So just going to jump in right here on number 1. All right, and once again, remember that we have our three main trig functions, right? And I'm going to write those all right here. So sine of theta is opposite over hypotenuse. Cosine of theta is the adjacent side over the hypotenuse. And then tangent of theta is the opposite side over the adjacent side. All right, so we're going to be looking for one of those three relationships. And remember, those only work in our right triangle. So notice the first thing I always look for is, do I have a right triangle? And if I do, I can use one of these three relationships. All right, so notice in this triangle, all right, I want to find I here. All right, I have 54 degrees here. So when I look, right, I also have the side opposite of 54, all right, which is 10. And then I also have I, or looking for I, which is the hypotenuse. So I have the opposite side and the hypotenuse, so that means I want to set up my sine equation here, all right? And I'm just going to do this on a separate sheet of paper here just so, all right, make it a little bit more room for you to see. So I'm going to write sine of 54, all right, degrees equals the opposite side, which is 10, over the hypotenuse, which is I. All right, so now when we think about this, once again, every time we set this up, this is a trig ratio. So we really have a proportion, all right, to solve. So remember, anytime I have just a one side, I can put it over 1 like that. So if I have a number, an expression, I can put it over 1. And now when I cross multiply, I do 10 times 1, which is 10. Then I do I times sine of 54. And remember, sine of 54 is a number, like square root of 3, something like that, right? It's just a different type of representation. So I can leave it as sine of 54 until the very last piece, right? And then I'm going to divide by sine of 54 here, all right? Just like if I had 2i equals 10, I would divide by 2, all right? So sine of 54 and sine of 54. And remember, the reason we want to do that is to make our answer as exact as possible at the end, all right, of our problem. So we don't want to round at the beginning and at the end. So then on my calculator, right, okay, I'm going to do 10 divided by and then sine of 54. And so remember that. That's just a number. And so I get 12.36. So I is 12.36. All right, so now, and this is kind of a, right, all right, kind of a riddle here. What tops off a Go Sunday, right? So we know I is 12.36, all right? And so then if I come down here and notice it tells us it wants to round our answers to the nearest tenth, all right? So that means I, for this problem, would have been 12.4. So I'm just going to come down here and I'm going to put in, find 12.4, and there's I. All right? And so once again, this is kind of like a self-check, right? So if you get a number that's not down here, that means you did something, all right, not quite right. Okay, so now let's look at number 2 here. And notice in number 2, I'm looking for a couple of things, right? So I'm looking for A, which is this side here, and then I'm looking for D, which is the measure of the angle here. All right, so now, all right, I'm going to start by looking for this angle, all right? And so when I look at this angle, right, I know the opposite side, which is 9, and then once again, I know the hypotenuse, which is, all right, 28 here. So I once again have opposite and, all right, hypotenuse, so that once again means we're going to be looking at sine, all right? But this time, when I set up my sine function, it's going to be sine of D, because I'm looking for that angle, equals to the opposite, which is 9, over the hypotenuse, which is 28. Now, remember what we talked about last time. We're going to have to take the inverse of both sides. Just like if we have x squared equals 4, we would take the square root of both sides to solve. All right, so the inverse of sine is sine inverse. So I get sine inverse of sine of D equals sine inverse of 9 over 28. And sine inverse undo each other the way a square and a square root undo each other, and that leaves me just D. And then I'm going to put sine inverse into my calculator here. All right, and once again, you have to find this on your calculator. I'll move my calculator a little bit. It's usually right above your sine key or your cosine key or tangent key or your trig inverse functions. All right, so I'm going to hit second sine inverse. All right, and then I'm going to just type in my ratio, 9 divided by 28. And that's going to be 18.7475, so I'm going to round that to 18.8. All right, and so that means that that angle is 18.8 degrees. So let's see if we have an 18.8, all right, down here. All right, so I think our 18.7, so it's probably this one. All right, so we'll put a D right there. All right, wasn't sure how far out they were rounding. Okay, all right, so now let's talk about A. Now, once I know this angle, I can technically set up a trig ratio to solve. All right, so notice now if I want, I can use this side and this side, all right, or I could use this side and this side. So I've got lots of choices here. I'm also going to show you a third way to solve for A, which some of you, all right, may already have thought about and maybe have already done. All right, but I'm going to go ahead and use a trig function. I'm going to use tangent because I have the opposite side and A is the adjacent side. So I'm going to say tangent, and once again, we know this is 18, and we'll say 18.7 since that's what it said below, so we're going to change that to 18.7. So tangent of 18.7 equals to 9 over A. And then once again, we can make this a proportion by putting the left side over 1. We can cross multiply 9 equals A times the tangent of 18.7. And then I can divide both sides by that tangent of 18.7 to get my value for A. That's 1. All right, and then once again, let's do 9 divided by tangent of 18.7. And that's going to be 26.6. All right, 26.6. All right, and so if we come down here, let's see, do we have a 26.6, 26.5? All right, so that's pretty close here. All right, so I'm going to say that that's an A right here. All right. Okay, and you can see why the rounding is a big deal, right? So even if I'm trying to carry through here, all right, it's still not very close, right? Or it's still pretty close. But if I round at the top and I round at the bottom, right, I may not be as close as I was here to pick that number out. Now, let me talk about a couple other things. So one is this, I use tangent here, but we could have used cosine, right? And I could have said cosine, right, of 18.7 equals the adjacent side over the hypotenuse. All right, so I could have done that. And then I would have, once again, made this a proportion, cross multiply, and A would equal to 28 times cosine of 18.7. And so once again, let's look at what happens when I do 28 times cosine of 18.7. I get pretty much the same number, right? 26.5. Right? And you can see that slightly different because of some of the rounding there, right? But I can get a number that's pretty close. All right, so I could have gotten 26.5 that way. Now, the third way that you could have solved for A here, all right, the third way is, notice we could have gone back to the Pythagorean theorem because I have two sides in my right triangle. So you could have, all right, worked with the Pythagorean theorem there, all right, and you could have said, okay, A squared plus 9 squared equals 28 squared, right? Okay, and then that would have been A squared plus 81 equals 2, and we could have done 28 squared, which is 784, which that means A squared equals 2, if I subtract 81 from both sides, 703. All right, and then notice I'm doing the inverse. I'm taking the square root of each side, right? So square root and square inverses, and that leaves me just the A. They undo each other in the same way the sine and sine inverse did. And I can take the square root of 703, and let me just move this here so you can see what we get here. And notice I get 26.5 again. All right, so the idea is that sometimes, right, you might have multiple ways, all right, to solve for a piece of a triangle. All right, and the key is if it doesn't ask for something, you have any way you want to use, right? So if it just says solve, right, you could have used any of those methods to get 26.5. Now, if it says using trig functions, right, then you have to use your trig functions and not the Pythagorean theorem. But that doesn't mean you can't use the Pythagorean theorem on the side to check your work to make sure everything worked out all right. Okay? And so I wanted you to see that. Now, notice the other thing was I had to use at least one of my trig functions to solve, all right, for D here. All right? So, because Pythagorean theorem is only dealing with sides, it doesn't give us a way to solve for angles. So you had to use that one here. Now, the other thing I will tell you is whenever you are solving, as much as possible, try to use the given information. All right? So, for example, let's say you solved for A first and got the wrong answer, and then you set up a trig ratio with A, right? Then that means A, right, would have been, and then that would have led to D being off if A was off, right? So that's the issue too with once I solve for this angle, right? And I set up another trig ratio to solve, right? So if I had messed up on this angle, made a mistake somewhere along the way, then my side for A would have been off. So as much as you can, try to use the given information if possible. All right, so I just wanted to go through a couple of examples, set everything up, show you a couple different ways to approach the problems. Go ahead and finish this lesson, and I will see you next time.